Yeah, good evening, everyone. Hope everyone tried the homework problems. Those which on your camps. Answer for this, everyone. Did you guys try this or forgot there is a homework question? Some of you forgot. Chalo, try. I'll give you 1 2 minutes. How do we do this? Any answers? This is an easy one. You just have to draw the FBD and little geometry and you would got the answer. Look at this thing. So if you on this, if you draw this sphere, if you extend this line, this will be theta. So the forces will be mg sine theta, mg cos theta. This would be friction F1, this would be friction F2, this would be N2, and this would be N1. From here we can see N1 plus N2 is mg cos theta. F1 plus F2 is mg sine theta. Since it is about to slip, frictions are maximum. F1 will be mu N1, F2 is equal to mu N2. Put this in the equation 2. We get mu N1 plus N2 is mg sine theta. And I know N1 plus N2 is mg cos theta. Basically, which we get the angle like angle of repose. So we get tan theta is equal to mu. What am I asking you to find? Find R by R ka ratio. Okay. Please check. The cameras, if you're not switching it on, I'll be just kicking you out of the classroom. So no worries about it.
So the tan theta equal to mu, we can directly get from the angle of repose thing we learned, right?
But did you derive that for this thing? Did you derive angular repose for this?
No.
Just because you got an answer tan theta is equal to mu doesn't mean you
No,
just
that's
applied
what I'm
wherever you
asking.
wish.
Can you treat it like the wedge thing?
So you tell me, can we? You think so? You think so?
Yeah, I
Give me
think
something.
can, na?
You think so? Or there is not even an iota of doubt, like 100% you're sure?
No.
No, no. When you're not 100% sure, don't do it then. Just simply solve it.
Okay.
Remember that thing in mind. If you're 100% sure, then use it. If you're not 100% sure, then just keep quiet and just draw the diagram and solve. Because exam, there will be no one to come and tell you what to do. When you're in doubt, do it from scratch. Don't make assumptions. Just because 2 plus 2 is equal to 2 into 2 doesn't mean 3 plus 3 is 3 into 3. It works sometimes. Then, what to find R by R1? So, I hope everyone did try these things. So, just a little geometry. It looks like that, but let's not make any assumptions because we derived that for a single block and single contact. I can say it works, but let's not. So that is theta here. So from here, from the center, if you drop a perpendicular, this will be 90 degrees. If you drop a perpendicular, this will be 90 degrees. This would be capital R. This would be smaller. This would be capital R. This would be smaller. So from here, if you drop a horizontal line, this angle is also theta. So from here, you can clearly see this difference here will be r minus small r. And this difference will be r plus r. So from here, we get sine theta. Yeah, that is sine theta, not tan. Sine theta is r minus r by r plus r. R plus r is the hypotenuse of the triangle. That's what we got. Sine theta is r minus small r by r plus r. And we also know tan theta is equal to mu. So if you draw a triangle, opposite side is mu, adjacent side is 1, and this will be root over 1 plus mu square. So sine theta is given by mu by root over 1 plus mu square. This is r minus r by r plus r. You can do that component to dividend thing, and you end up with r by small r mu plus root over 1 plus mu square by mu r minus r plus r by r minus r. Something of this sort. Check. That will be final answer. Okay, they're asking reverse r by r. So you can just reverse it. Please check. This comes from geometry here. So this was easy. Once you got tan theta is equal to mu, little geometry, and we get it from here. R minus r is the opposite side, and r plus r is the hypotenuse. You can just cross multiply and change that. All clear with this? Easy? This was easy. How did you guys do this thing? This is a pretty good one, right? You have a massless rope over a rough fixed cylinder and both the sides you have M1 and M2. Question is find M2 by M1 if the system is at rest. Any answers for this? Anyone tried this? You got any answer here? You can type here in the chat box. This is a little different. Think about it for a minute. I'll show you. If you have not tried, then you should have tried it. Now, see, if you see, there are two possibilities, okay? M2 can be so heavy, then what would happen? The whole system will go this way. If M2 is too small, then the whole system will go this way. Got it? So you always get a range here. So let's see what is happening here. If M2 is greater than M1, then M2 would go down. So if you draw the FBD of the rope, okay, rope is about to slip. We are taking the extreme case. If you look at the forces, this guy will be M2G, this guy will be M1G, and since it is about to slip on the right hand side, the friction would be like this. Are you getting this? That entire rope will have a friction along the string because the whole thing is trying to slide to the right side. Rope is about to slip, towards right. Now see how to do this thing. Similarly, this is a M2 ka maximum case. Similarly, if you take the other case, if M2 is less than M1, then there's a chance that FBD of the rope will go to the other side. Listen carefully, right? This is important. So when you take that semicircle thing, I'm exaggerating that semicircle thing. Take a small piece here. Take a small piece d theta at an angle theta. Consider a small piece of rope. Now look at the forces acting on this. This would be tension plus dt. This would be tension. And this would be your friction df. And this would be your normal reaction on this small piece. Right? I'll do one thing. I'll just make this straight so that it is more easy to see. Because anyway, gravity won't matter here. Gravity is neglected. So we are talking about these forces here. We have a tension T. We have a tension T plus dt. And we have a friction dF. So if I just write all those things here, tension T plus dt, the friction dF, normal reaction. Agreed? These are all the forces here. So from the center, if you look at these angles again, remember this thing, this is useful. Again, we will encounter this thing in circular motion. So for this arc, if you drop a perpendicular bisector, this would be d theta by 2, and this would be d theta by 2. And when you drop a tangent here, this would be 90, and that would be 90 minus d theta by 2. This would be d theta by 2. So you can take out this tension ka components. This would be d theta by 2, and this tension ka components d theta by 2. Now look at the diagram here, what we get. In the vertical direction, we get normal reaction is equal to T cos d theta by 2 plus T plus dt cos d theta by 2. So the rope ka two tensions are actually pushing this rope, downward, that is generating the normal reaction. And similarly, T plus dt is balancing tension plus dF. These are the two equations. Just let me simplify this. So we can write this thing n is equal to cos d theta by 2. If theta is very small, then cos theta is almost equal to 1. So this will be T plus, that is negligible. Let me write here this thing. So cos theta is approximately
won't it be
1.
sin theta?
वो sin था रे, you're right. Sin the vertical component, you're right. Sin theta for small angles will be approximately theta. So normal reaction becomes T d theta by 2 plus T d theta by 2 plus dt d theta by 2. Since already dt is very small and d theta is small, this is negligible. So from here we got the normal reaction is equal to T d theta. This is equation 1. Please have a look at this. These are the horizontal components you're talking about. Please check this. You can see what we did. We took a small piece here that I'm exaggerating and drawing it here in a big piece. I just kept it straight so that it's easy to see the angles. On both the sides, the tension won't be same. Because of this friction, right, the tension will slightly change. So we get T plus dt, and this will be T, and the friction is dF tangentially. So these tensions ka vertical components are balancing the normal reaction, and the horizontal components are trying to balance the friction. So I wrote the vertical direction ka equation. So from there, I found normal reaction is T into d theta, where T is the tension and the strength. Is this clear? Everyone, please check. Now, if I try to write the horizontal equation, we get T plus dt should be equal to the tension plus the friction dF. Tt will cancel. We get dt is equal to dF. And we know the friction is always less than equal to mu into n. So we know dF is also equal to mu into n. So we get dt is less than equal to mu into n. And what is n? Just now we calculated mu into n is T d theta. Shift this side, we get dt by t is less than equal to mu d theta. Integrate on both sides. you end up with integral Tt by T is less than equal to integral mu d theta. This will go to tension on the left hand side or the right hand side. That would be from M1G to M2G. This would be ln T by M1G by M2G. Let me do one thing. I'll do more general. T1 by T2. You end up with ln T2 by T1 is less than equal to mu theta. So we get tension should be less than equal to T1 e power mu theta. You get an exponential function. This is the horizontal direction. Again, please check what I did. So vertical forces are balanced with the normal reaction, whereas the horizontal, the difference in tension dt is due to the small friction df. And we know friction is always less than equal to mu into n. And n is, we know, t d theta. Just now we calculated. When you integrate this, we got that ln T2 by T1 is less than equal to mu theta, or T2 is always less than equal to T1 into e power mu theta. Let me tell you what it means exactly. What this thing is telling you is, if you have taken a rope with an angle theta, and if you say this side the tension is T1 and if this side the tension is T2, because of this friction here, the tension between these two T2 by T1 will be in this ratio, where theta is the angle between the 2 points of the rope. This is T1 and this is T2. I took from 0 to theta, no? Big deal, doesn't matter. I'll show you still. Because the right side is the M2 block, I'll take that as T2, and M1 block, I'll take it as T1. This is quite an important result. Huh? What is the meaning of this result? I'll turn it back. Listen carefully. The meaning of this result is when you took this rope here, if you take this block as M2 and this block as M1, and if you want the whole system to slip to the right side, so at this point here, the tension T2 will be M2G, and here the tension will be M1G. So this value M2G, so this T2, I want to slip this side, the friction is that way. So T2 should be less than equal to T1 into e power mu theta. So this would be M2 should be less than equal to M1 into e power mu theta. Vice versa, if you want to do it in the reverse direction, so this time friction will be this way. This time friction will be opposite. So this time this tension will be greater. So this time you'll get T1 is less than equal to T2 e power mu theta. We get M1 is less than equal to M2 e power mu theta. Or you can simply write M2 by M1 is greater than equal to e power minus mu theta. There, this is your final answer. The ratio M2 by M1 will lie between e power mu theta by e power minus mu theta. These are the two cases which we get. If you go to the right, whichever side you're going, right, the tension is stronger by a factor of e power mu theta. Please have a look at this. Again, I'll explain the whole thing. Listen, like I said, it's complex. It's more of a little math oriented. At an angle theta here, take a small piece here, d theta. On this d theta, there are 4 forces acting: T plus dt, tension on the other side, friction, and normal reaction. Why the tension is T plus dt? Because as you go up, because of that friction, the tension is slowly changing. And vertical direction means so T plus dt ka vertical component and T ka vertical component are balancing normal reaction. So from there I found N. Since for small angle sin theta is theta, sin d theta by 2 can be written as d theta by 2. And here we get dt and d theta. dt is already small, d theta is already small, and you're multiplying two small quantities. So it is negligible. So from there I found the normal reaction in terms of tension and theta. I took this guy and I kept it in the horizontal equation. And from here I found out the tensions are in the ratio of T1 by T2 is less than e power mu theta. So what is T1 here and what is T2 here? So T2 is that smaller tension. You can just remember like that. Or the tension, on which side the block is trying to go, opposing. Tension which is opposite to the motion of the string. So basically here I assume T1, T2 are going like this. Just like the smaller tension, that is better, that is understood. And T1 will be the bigger tension. Now who is bigger, who is smaller will totally depend on which side the rope is going. So if you assume the system is going this way, in this case, T2 is greater than T1. If you're assuming it is going the left side, then T1 is greater than T2. Just to take it a little further, so from there we get the ratio m2 by m1 is e power mu theta and m2 by m1 is greater than e power minus mu theta. As long as this ratio is between these two values, you're safe. The rope will not slip. Anything more or less, you have won. This is slightly out of portion. You can handle it, but a little different. So the meaning of this, you know what? Think of like this example. I'll just on the page. Suppose if you take a rope here, some kind of a pole, and if you try to tie a rope, let's say this is one turn, this is two turns, and then three turns, and you take it like this. So if you pull this side with a force F, and if this side you tie a block M, you know how much force you require to stop this block from slipping, or let's say like the other way around. So if I take this as F2 and if I take this as F1, so here we have 1, 2, 3, 3 turns. So in order for this rope to slip, let's say you want to move this F2. Yeah, this is only confusing. You have to decide the direction. Okay, we'll do it like this. So to move the block up, the entire rope has to slide, right? To move the block up, this force should be greater than or equal to mg e power mu theta. Here theta is 3 turns, so 3 into 2 pi. If you have to apply at least this much force, e to the power of 6 mu pi. Then the whole block, then this rope on this thing will slip. To move the block down, F should be less than or equal to mg e power 6 mu pi. The other way around now. But I think this point is clear. So if you look at this thing, right, you will see these kind of knots, on ships. Where is the friction? something like this. So that means if you take a rope and if you make it go around the pole, it does not depend on the radius of the cylinder. It just depends on how much you're rotating. If you just make it go around the pole and if you take it back, you can actually generate much more force. It's very difficult to slip. So this is what they do, during the ships and everything when they tie the sails, instead of, bringing the rope and tying like this, they take the rope, they make it go round, and then they tie it. That is much more secure. Even if you apply just 10 newtons here, you can generate at least 1000 newtons here. You can balance a force of 1000 newtons with just a small 10 newtons. Meaning, just look at this thing now. Example, if you take mu is equal to 0.1 also, simple thing. This would be mg e power 0.6 pi. Pi is almost into 3. So that is almost 1.8. Exponential is 2.7. So even if you take it as 2, that would be like 2.5 ka square. That will be 6.25 mg approximately. With a friction of 0.1, you can balance a weight of 6 times more with just the force F. So taking a rope and going around the pole, right, will generate a lot of force. It's very difficult to remove actually. So this is how people normally tie the ropes, This is much better. Please have a look at the calculations. It is mathematically a little weird, but it's really not that difficult. Again, we're just drawing the FBD and we see this. It does not depend on the radius of the cylinder. Where R is not there only. It's a massless rope, right? So R won't matter actually. That is one more thing. Means you take a big thing or a small thing, doesn't matter. What actually becomes a deciding factor, you know what? After tying so many times, this force and this force will become so high, the pillar actually breaks. The wooden pole breaks. It generates so much tension. Even before it slips, the pole itself will break. I just took 3 turns. You could have taken 10 turns. You could have generated huge force. Even 1 Newton can balance something like 100 Newtons. That is the kind of force ratio we are talking about. And there's a reason why this happens. Think about it. Look at here. It is there here only. If tension is more, there is more normal reaction. If there is more normal reaction, there is more friction. If there is more friction, there is more tension. You're getting? The function is increasing itself. If you increase tension, that will increase normal. If normal increases, friction increases. Because friction increases, T will increase again. This is a function which is, increasing itself continuously. That's why the value blows off exponentially. And look at this example. So depending on which way you're going, if you're going to the right side, T1 is small. If you're going to the left side, T2 is small. And you're done.
So can you show that rope example for a minute?
That theta is the angle rotated by the rope around the pulley. So in our case now here, this is a semicircle, right? Theta is 2 pi. Theta is pi. I'll just show because it's a semicircle. Rope is along semicircle. If you want to move the block up, you have to pull the rope with the force of at least mg into e power 6 mu pi. Mu is the friction between the rope and the pole. You can try this at home and see. Take a rope and put it across and try to pull and see. You'll find it is more effort. The more turns you make, it will become more difficult to pull. Clear? Interesting part is exponential. You don't get a linear function. Next one. Let's see an easy one. Can I turn the page? All clear with this thing, no? Abhinav, clear, no?
Yes, sir.
Ritu, Anusha, clear? Vidyut, clear? Ritu, clear, no? Great. Udayan, got this? Make sure to try this again on your home. When you see this thing, you feel like, we understood. But trust me, you try to do this thing, you'll get stuck in the middle. And make sure to do this thing because something similar we will see again in circular motion. It helps you there. Let's say an easy one. This is a standard problem here. We have a mass m, friction mu. This would be straightforward bits or mains question. Find minimum force required to move the block. Get this? It's not mu mg. It's not mu mg, right? A standard result, you have to mug up the result. It is not mu mg, gods. I never told you force is horizontal. I said minimum magnitude. Try. I'll give you a minute. Yeah, CET bits, this kind of exams, direct result, this will come. Get this. This is easy. Area. Since I don't know how is the force, let the force be at an angle theta. If you want to take it horizontally, don't make an assumption. You take theta and theta 0, prove karo. What are the forces acting on this? F cos theta, F sin theta, friction, normal reaction, your own weight mg. So the point here is by applying force at an angle, the normal reaction can change. Therefore, friction can decrease. Mg minus F sin theta. Since F cos theta is equal to F, since it is about to slip, F cos theta is equal to mu n. So this would be mu mg minus mu F sin theta. Then you get F is equal to mu mg by mu sin theta plus cos theta. So basically, this is the force required to move for a given theta. Now, to minimize this function, this denominator should be maximum for minimum force. And we know from trigonometry, a sin theta plus b cos theta is less than equal to root over a square plus b square. So the F minimum will turn out to be mu mg by root over mu square plus 1. This is your minimum force, a standard result, which you need to definitely mark up. So the point here is when you apply force at an angle, some of the force you can use to decrease the normal reaction, which in turn will decrease the friction. So it works out. Theta is not 0. If you observe, this is less than mu mg. This value is less than mu mg. Check. Yeah. The mistake you guys were doing, you're thinking it will be hot force is horizontal, not necessary. Clear, everyone? Next one. Neil, clear with this? Rehan, easy? Rehan, clear? Niranjan, got this? The maximum force will be negative of this value. What do you mean by that? Negative of this value meaning? Minus of root over a square plus b square. That means you're applying force if you're taking FPR magnitude, no, you're asking. Clear? Next one. Let's say we have a wall here. We have some kind of floor here. We have a chain here. Like this. So the chain is hanging here. This point here is fixed. Chain ka mass is m, length is l. This chain on the floor is L by 3. And the floor is rough mu. Angle theta and gravity is also there as usual. So this thing is almost there flat actually. It is like this. Find theta if the chain is about to slip. So some part of the chain is hanging and the 1/3 of the part is on the rough floor, flat. The chain is on the verge of slipping. So find theta. Meaning the weight has become so much, if you just push it right, the chain would something become like maybe like this. It will just start gliding and then it will completely fall down. Friction is mu on the floor. The answer will come in terms of mu. Get this is an easy one. Aditya, I think you are right. Aryan, you're wrong. Others answers, I want answers here. Everyone should type. Try. I'll give you a minute more. Just an FBD, draw an FBD for the hanging part and draw an FBD for the horizontal part. See. if you took the chain, the hanging part, this will be tension, let's call it T1. Let's call this thing tension T2. This is angle theta, so this is also theta. And the weight of this part will be how much? 2 mg by 3, because it's a 2/3 of the chain. So we get from here T2 cos theta is 2 mg by 3. And T2 sine theta is equal to T1. Now on this horizontal part of the chain which is hanging, this would be T1. This would be mg by 3 because it's only 1/3 of the chain. Friction would be this way and this would be the normal reaction. Since it's on the verge of slipping, T1 will be equal to friction, which will be equal to mu mg by 3. And then you're done. So equate this, take it and put it in this. T2 will be 2 mg by 3 cos theta, that becomes tan theta, and T1 will be mu mg by 3. mg by 3 goes off, tan theta is equal to mu by 2. If I had given you mu is equal to 2, then I would get tan theta 45. I can adjust the values. Check. So you just cut the chain at this point here when it is about to become flat. I know they should have drawn it more flattish, but okay. Easy. Clear? Next one. Next one is a good one, right? This is a conveyor belt top view. So we got a conveyor belt here, which is going horizontally. So conveyor belt moves with constant speed. Three meters per second. Speed of the belt is 3. This is the width of the belt. Then what you did, you took a coin and you projected inside with a 4 meter per second along the width. So you can treat this thing as y-axis and treat this thing as x-axis. So a coin is projected. So coin enters perpendicular to the velocity of the belt. It need not go along that line because of friction and all. Belt ka friction is 0.5. Belt is not smooth. Perpendicular to the velocity of the belt. With 4 meters per second. The first question, find the minimum width of the belt so that the coin does not cross the belt. You don't want the coin to go and fall down on the other side. Find the minimum width so that the coin does not cross the belt. find the minimum speed of the coin. So during this entire process, the coin will have a minimum speed at some point. What is the minimum speed? Let's get this. I hope the question is clear, everyone. There is a conveyor belt going with 3 meters per second, constant friction is 0.5. You took a coin and you hit it from outside, and this coin tries to enter perpendicular to the conveyor belt. But because of the friction on the belt and all, it won't go straight. It'll actually start bending. That it doesn't matter mass of the coin. You can take it as m, it'll get cancelled off. When you write mu mg is equal to m cancel ho jayega. So find the minimum width so that the coin does not slip. 1.6. Mere Aditya, that's not the answer. And find the minimum speed of the coin. Try. You got 3 minutes for this. Think about it. It's a good one. This should be a proper advanced paragraph.
So,
हाँ
so cross the belt means does not fall out, right?
हाँ उस साइड नहीं जाना चाहिए.
Oh,
It shouldn't cross the belt. Shouldn't fall on the other side. Anyone is confused with the question card diagram, please ask. I just kicked out 3 people from the class because their cams are not on. Aryan is the answer to the B part. Aryan, think about it, na, logical. One thing, tell me everyone. Finally, when the coin stops, uska speed kitna hoga? 3, right?
meter per second.
3.
3, na? As the coin will slide, something happens, it will stop. It will go with the speed of the belt, isn't it? The final speed is 3. Someone got the width. How much? Aditya, that is right. We have one answer, everyone, for the first part. Get the speed also. First, get the width. Venkatesh, do keep your cams on. There is an issue with the cam. You're supposed to message me before the class starts. Venkatesh, I can't see your face, right? Yeah. 16 meters, Adrit, नहीं रे, बहुत ज़्यादा आ गया. 16 is like, isn't it too big of a belt? Near, you're giving all weird answers. You need to switch off your cam, not a problem. Just leave me a message. I'll be back. I'm going for water. Just leave a message, switch off the cam, 3-4 minutes, I don't mind. But if you switch off randomly, I'll assume you're sleeping and eating something good. One of them. 0.75. No, Ronak, that's not the answer. Abhinav, 5. That's not the answer. Sure, let me help you out. The first part, since the belt is going with a constant speed, let's solve with respect to the belt. Stop the belt basically, right? So when you stop with respect to the belt, there is no pseudo force. Since velocity of the belt is constant, pseudo force is 0. So basically it's an inertial frame only. So the moment you stop the belt, this is what it looks like. So if you take a person on the belt, this guy will think the coin is having a speed 4 meters per second and 3 meters per second this way. So he will think the coin is going this way with a speed of 5 meters per second. And this angle will be tan theta 4/3 at an angle of 53 degrees. Now so look at this thing. As this coin is going here, how will the friction be? Friction will be backward. Acceleration will be this way. So F is equal to mu mg, because it is sliding, is equal to ma. A is equal to mu g. Mu is 0.5. So this would be 5 meters per second square. So this is the whole scenario there. So we got a coin here going with a speed of 5 meters per second. This is your initial speed. This has an acceleration a, which is 5 meters per second square. This guy will go till here and stop. With respect to belt, v is 0. So we can use the formula v square minus u square is 2as. V is 0, u is 5 square, acceleration is backward, so minus 5 into s. S is equal to 2.5 meters, but this is not the answer. Because what you got is the slanting length. What you got is this length. So you want the coin to just go and stop on the edge. This you got is 2.5 meters. What I asked you to find is the width, the black line. And this angle is 53 degrees. So sine 53 will be the opposite side width by 2.5. Sine 53 is 4/5. So 4/5, the width will be 2 meters. Check, that's your answer. Right, Anusha. So basically, if you go and stand on the, you have to minimum value, matlab, ye pura, throughout this motion, find the minimum speed of the particle till it stops. Initially, it is 4 to find the minimum speed of the coin. I hope everyone is getting it. If you stand on the belt and see the problem, it looks more easy. It is just going in a straight line. Since belt is going with a constant velocity, there will be no pseudo force, nothing. Belt will think coin is going with 5 meters per second at an angle of 53 degrees. Friction will be opposite to, remember, friction will be opposite to relative velocity. Friction does not oppose motion. Friction opposes relative motion. Friction is opposite to relative velocity. So when you stop the belt, whatever velocity you get, uska opposite the friction will be. If you try to do in the ground frame, it looks quite complex. But with respect to the belt, it is easy to see. It is just a straight line motion 1D. So the coin goes there and just stops here. Means it's on the almost on the edge. It will fall off if you push little more. So you travel 2.4 meters at an angle. Find the width from there. Is the first part clear, everyone? Please check. Find the minimum speed. Try. I'll give you another 1-2 minutes. Minimum speed is a good one. Like I said, this will be a proper paragraph level question. This is first one, and the second question will be the minimum speed. Generally, advanced, whenever you get paragraphs, right, one will be easy to do, and other one they will slaughter you. How do you find the minimum speed? This is a good one. This is the second good one today. After that, that rope around the pole. This would be the second good question today. Remaining are good ones, but yeah, these are a little better. Next class we'll wrap up the chapter, and let's see. Next class, time permits, maybe we'll start off with circular motion introduction. This week there is no test, like I said. I'll be posting the schedule in some time. This week it became a little mess actually. Your seniors ke saath na, it is kind of loaded. These people have gone mad. I think I told you this thing, right? They started a 10th track. 10 tracks are going on for them. Your seniors are going mad. 5 tracks of chemistry, 3 tracks of physics. It is pretty weird. I don't know what they're trying to do. And they say, like, we'll finish up the syllabus, the revision start karenge. And in revision, what they do? They say revision, they give some 10 problems, and 2 hours they do time pass. They actually ignore everyone and throw them out. They do nothing in the revision. I'm seeing from 6 years. Bullshit revision they do. I think they're having short of faculty, I guess. They don't have enough teachers to, put extra lectures for you guys. So they're trying to rush off telco portions so that they can use teachers for you. Something like that is happening. Anyways, that is there what is happening. Luckily, all your seniors stopped going to PACE. What about the second part? Just wait for 2 months, you'll become seniors. Any answers for the second part? Listen, let's stop the, let's see from the belt and the ground frame, you will observe something. So when this coin is given speed 5, as this is traveling at any instant here, the speed will be u minus gt, that will be 5 minus 5t. Agreed? This is with respect to belt. We know velocity of coin in the ground frame is velocity of coin in the belt ka frame plus velocity of belt in the ground ka frame. So I want minimum speed. See, when I say find minimum speed, I'm talking in the ground ka frame. Always, if I don't mention anything, it is always ground ka frame. So we have 2 velocities here. One guy is going this way, 5 minus 5t, and the belt itself is going this way with 3 meters per second. So I want the resultant of these two to be minimum. And this angle is 53 degrees. Now see, this is what I do. We split this thing, velocities, perpendicular to 5 minus 5t and parallel to this thing. We divide like this. I'll show you why. So if you divide velocities in this direction, this angle also will be 53. So this components would be 5 minus 5t. This would be 3 cos 53. This would be 3 sin 53. No, I wrote reverse. This is 3 sin 53. This is 3 cos 53. So we have 2 velocity vectors. 5 minus 5t minus 3 cos 53. How much is cos 53? 3 cos 53. Okay, now let it be like that. 3 cos 53. And this component is 3 sin 53. So the resultant speed will be velocity of the coin in the ground frame will be root over, square and add these two guys. 5 minus 5t minus 3 cos 53 whole square plus 3 sine 53 whole square. This is the speed of the coin at time t. Now, in order to get a minimum value, this term here should be 0 for minimum speed. Because see, this is constant. You can't change this value. This is the only value which will change with time. So I can put a value of time such that this has to be 0. This has to be 0 for minimum speed. Therefore, we get V minimum will be 3 sine 53. Sine 53 is 4 by 5. 12 by 5 is 2.4 meters per second. Means for a moment it will be even speed lesser than the speed of the belt. Now, why did I divide like this and why didn't I divide it normally? T is time, right? This is the velocity after time t, right? V is equal to u plus at I'm using. This is the velocity of the coin with respect to the belt. It is going in the opposite direction of God. Why can't it go slower? If you're running on escalator in the reverse direction, your speed is less than the ground, less than this thing. They'll subtract. So initially it will go slower and then the speed will again increase. Now see, why didn't I subtract the other way around? Why didn't I take horizontal components? Because 5 minus 5t, and this is some 3 sine 50, 3. If I take components, देखो क्या आएगा? This will be 5 minus 5t cos 53. 5 minus 5t sine 53. When I square and add them, I'll get root over 3 minus 5 minus 5t cos 53 whole square. 5 minus 5t sine 53 whole square. There is a time here also, there's a time here also. Are you getting it? Both are changing. How will I know which is the minimum value? I have to do maximum minimum then. Differentiate karna padega. You're getting the problem? Both the terms will have time ka term inside. And I don't know, like, I can't see and guess like, yaar, for minimum ye hona chahiye. But the moment I kept the time ka term as it is and divided 3, see, there's only one, there are two terms inside, but one term has time, the other one is constant. I can clearly see and tell here, if this guy becomes 0, you get a minimum. Are you getting why I didn't do that? If you want to divide it normally, you can do that, but then you have to do maximum minimum again. So that is unnecessarily one more additional step. This is the only variable. So keep that guy as it is. Don't mess with that. Divide the other ones along and perpendicular to it. If you divide 5 minus 5t, you're making 5 minus 5t into two parts. So you'll get two variables. So this term also will have time. This also will have time. And it becomes difficult to solve. That's it. More of a pure mathematical reason than physics concept. Please check. This is your B part. Anyone not convinced with this, not clear with any particular step, please ask. You guys should definitely do this on your own again. See the question, spend 10-15 minutes, it is worth it. Relative motion, friction, we are doing everything. Udayan, clear with this? Venkatesh? We can find the path of the coin. You can find. तो यहाँ से जा रहे हो ना, ये कोऑर्डिनेट क्या होगा? This s is equal to ut minus half at square. So this is 53. So I will get this thing is how much? S cos 53. This will be S sin 53. Agreed? Plus, this is going forward how much? 3 into t, na? So what is the x coordinate? 3t minus S cos 53. What is y coordinate? S sin 53. There, na, you got your x and y coordinates. Clear? It won't be a straight line. Straight line तो नहीं होगी. It's changing the time. नहीं, इसमें भी time है. There'll be this S also has t and t square. It won't be a good path. It won't be a good path in the ground frame. It looks pretty weird, I guess. In ground frame, it would look something like slowing down also, right? So if you're projected here, something like this. It will eventually become a straight line going horizontally. It is a little difficult to draw, but you can find x and y coordinates with respect to the belt and just add the horizontal component of the belt. All clear with this? Any doubts on this thing? Please ask any step you're not clear. So you find the velocity of the coin with respect to the belt, and then you find the velocity of the belt, and then you add them vectorially, and you get the velocity as a function of time t. And we can clearly see there are two terms here, and that one term becomes minimum. You have to just make that variable term 0. All clear with this? The next one. Now, this next problems are quite important. 2 block problems. 3 blocks we don't have in the portion, but we'll do 1 or 2. Now, listen to this carefully. I think this is the last type of model that we have in friction. I can create much more, but we did them all main ones. So we have 2 blocks here, 3 kg, 2 kg. The ground is smooth. This friction is 0.2. And you're applying a force of 4 newtons. Find the acceleration of blocks and friction between them. Okay, this is an easy one. But this will put a starting point for this kind of problems. Let's see how much you actually understood friction. Let's get this. I'll do one thing with. Let's call it F. Case 1, F is equal to 4 newtons. Case 2, F is equal to 20 newtons. There. So if you apply 4 newtons, find the acceleration and the friction between the blocks. If you apply 20 newtons, find the friction and the acceleration of the blocks. Try. I'll send you sheet on friction today. Did I send you a friction sheet last class? No, I'll send you today. Not much, maybe 20-30 problems. But again, I'm telling you, number 1, you should actually revise your notes again. People who are not scoring 50-60% in the exams, the reason why you're not scoring even 50-60% in your classes exam or my exam or any exam is because you're not doing revision multiple times. You're getting it. You are supposed to revise. For example, laws of motion chapter got over. We did almost, 45-46 problems. You should have revised the notes at least 3 times. Multiple revisions are important. Sabko kya lagta pata hai? Instead of that, you guys try to do n different things. I will do this book, I will do that, I will do this. This is for people who are scoring less than 60%. First of all, you need to put 60-65% score in every exam. Repetition is what is more important. Because most of you guys, what I'm observing, I give you a question, you see the question and you say like, arre, ye class mein kiya tha, but I don't know what to do. Happens? Arre, this question I saw in the book, but I don't know what to do. This happens a lot with you guys. You just recognize the question, but you don't know what to do. That is because you guys are not repeating it 2 to 3 times. Your Ekanksha batch, if you see, right? Ekanksha batch, this Anuju is there, about 550, 540 rank kuch. These people literally, that entire batch, I'm telling you, chemistry, so they revised at least 4 to 5 times. Full syllabus. Physics at least 3 times. Chemistry needs more revision. You need to revise. So for people who are struggling with marks, your main mistake is not solving enough. It is your not solving enough revisions. You're not doing enough revisions. Let's see this thing, how to do. Yasha, you're wrong. And that's the best part. Aryan, you're wrong. Anusha, you're right. But what about the friction ka value? Let me show you what you guys are doing. Free body diagram. F, 4 newtons. Friction. This will be mu into N. This is 2 kg. This is 0.2 into 20 is 4. This is 3 kg, so friction will be forward. This acceleration is A1, this acceleration is A2. So we get A1 is 0, we get A2 is 4/3. This is a blunder. Can someone tell me why this is a blunder? How do you know that friction is maximum? Are you sure it is slipping? How do you know F is maximum? When are you supposed to take maximum? If you're 100% sure the blocks slip, then you should take F is maximum. Are you getting this? So how do you solve this kind of problem? Listen, how do you handle this kind of problem? Everyone, listen carefully. This wordings which I'm saying are important. We don't know how is the friction. So what we do, this is how we draw the FBD. F is equal to 4. Friction, I don't know. I don't know whether it is slipping or not. Let this. So this is how we start actually. Assume both the blocks are going together. Because tell me one thing, what can happen? Either they're going together or they're slipping, right? Can anything happen? Both are going together or they're slipping over each other. So this is how we start these problems every time 2 blocks. Assume both the blocks go together. We start with an assumption. Two kg, 3 kg. We have F is equal to 4 Newton. Since both are going together, I can take acceleration. A is equal to 4/5. Okay. Now, take any one block. I will take the 3 kg block. We get friction is the one who is pushing it. F is equal to 3A. And this will be 12/5 Newtons. What is the meaning of this? Now, listen here carefully. What we got here is 2.4 Newtons. This is the required friction. Friction is telling you, if you give me 2.4, I will make sure both the blocks go together. Are you getting the meaning of the statement? Friction is saying, you give me 2.4, I will make sure both go together. Since F required is less than F max, which is 4 Newtons, blocks go together. My assumption is right. Are you getting what was the assumption? Both are going together. So for that assumption to be right, how much is friction asking? 2.4. How much can you give? 4. My assumption is right. Problem got over. So what is the answer? Acceleration is 4/5. And what is the friction, everyone? 2.4, no? It is not 4 Newtons. Are you getting this? You are supposed to give only how much I'm required. Now, the mistake you did in this thing is, observe this. This looks so weird. This is 4 Newton. Agar ye bhi 4 Newton, to ye block rest mein tha. But the bottom ka block is moving. Can you see the absurdity of the problem? You're pulling the upper block, that is not moving. The block below this thing is sliding. Just imagine in your house this happens. You have your dining table, you keep a water bottle or something, and you move the water bottle. Water bottle doesn't come, but the table goes. There's a ghost in the house. Are you getting what is happening? That is what it is happening there. You did a mistake by assuming F is maximum. Please take the steps what I did. Assume both the blocks go together. Find the acceleration. Find the friction. This friction is the required friction. So friction is saying, you give me 2.4. I'll make sure both can go together. I can give you up to 4. So I think the assumption is right. So friction gives 2.4 and they both go together. Is this clear, everyone? Huh, Abhinav? Palaksh? Clear with this? Venkatesh? Clear? Ritu? Sure, na? Maulika? Clear? Swastika, got this? Anyone not convinced with this, please ask. This is very important. 2 block problems, you always start like this. Let me show you the second case, what happens. 2 kg, 3 kg, you're applying force is equal to 20 Newtons. Again, start the problem. Assume both the blocks to get together. Why are we assuming? Because I don't know. You're getting the point is I don't know whether they're going together, whether they're slipping. हमको कुछ idea नहीं है. So always start an assumption. assume both the blocks go together.
So why can't we assume them to be at rest?
How can they be at rest when ground is smooth? Who is stopping them? Who is stopping them? And the ground is at rest. You tell me who is stopping that F? You took both as one system. Bata, kahan pe force? They have to move.
Okay.
Or they go together. There is no other option. Okay? If there's a friction on the ground, then what you're saying is right. That we will see later on. So, you're taking F is equal to 20, and this is acceleration. This is 2 kg. This is 3 kg. Acceleration is 20 by 5, which is 4 meter per second square. Choose any one block. I will choose 2 kg block. It doesn't matter. Take any block you want. This F is 20. Friction should be backward. This is acceleration. 20 minus friction is equal to 2a. A is equal to 4. We get F is equal to 12 newtons. You know what is this? This is the required friction. Friction is saying, if you give me 12 newtons, the meaning of this statement, right? This is what you should understand every time when you get this value. This is saying, if we give F is equal to 12, blocks will go together. That is the meaning of it. That is the required friction. It is saying, give me 12. I will make sure your assumption is right. But we know, so this F required is 12. F max is 4. So since F required is greater than F max, my assumption is wrong. What is the assumption? They're going together. Therefore, blocks slip. Are you getting it? Now what to do? Ho gaya na? You proved blocks are slipping, right? Since blocks are slipping, now you can take F max. I'll turn the page. So this is F is equal to 20. Again, redraw the free body diagram. This is F max. Since we know it is slipping. So first you have to prove it is slipping before using the word F max. Wo problem tha. These questions, this is how you should always handle. Acceleration is A1. 20 minus 4 is equal to 2A1. A1 is equal to 8. So once you got that, you have to draw new FBDs and solve again. Whatever we did, everything was wrong. This acceleration is A2. This is 3 kg. So A2 will be 4 by 3 meter per second square. As expected, both are different. You have to draw an FBD again and solve. See, because the main thing is what once you know it is slipping, your life is easy. You can put F max and finish it off. But before that, you have to prove. Please check how we did this. Yeah, right, Venkatesh. So in the second case, friction is maximum. Is everyone clear with the 2 blocks how to handle this? Please check, ask me if you're confused. Yeah. The blocks are not moving together. Obviously, they're not going together, matlab they're slipping. They have relative velocities. Clear? Can I go ahead? Everyone? Ronak, clear so far? Niranjan? Clear, na? Neil? Yasha, clear with this? Udayan, got this thing, na? Next one. We have 2 blocks, 2 kg, 3 kg. I'll keep the numbers same. The ground is smooth. Let's say this friction is 0.2. You're applying a force F on the lower block. F is equal to T. T is time. Means force is not constant. How did we get 12? We calculated it. We thought the friction was, we thought both are going together. we found acceleration, and from there we found the friction. Huh, Monica? Sure, no? So basically we took it as 4, then we got F is 12. Now see, the meaning of this is, if you give me 12, my assumption is right. But can I give 12? I can't give 12. I can give maximum 4. That's why my assumption is wrong. ये पूरा गया. तो वापस resolve करना पड़ेगा. You have to draw a new FBD and solve. Got it? You always have to prove. So here we have a force changing with time. So plot acceleration of the blocks versus time graph. Let's get this. These are good ones because देखो, if I put F is equal to T0, 1, 2, 3, I'm getting the value of acceleration for all forces. Means sometimes for some time they'll go together, after them they'll slip. If you can handle this, you know how to do 2-block problems. But we will see more variations of this. Get this. How do we do this? Think for 2-3 minutes. I'll show you one, then I'll give you one more like this. Let me help you with one. I think with time, na? Yes, that might be confusing. Sure, let me show you one. Listen carefully how I do this. Step 1, assume both are going together. Just listen carefully. Assume both are going together. Since I don't know what is happening, we always start with an assumption. Acceleration is A. So we get acceleration is equal to T by 5. Choose any one block. You can take 2 kg or 3 kg. I'll take the 2 kg block because I want to find the friction ka value. So the reason why 2 kg is moving is because of friction between them. So F is equal to 2A. So I get friction is equal to 2T by 5. But I know friction ka value is less than equal to mu n, which is nothing but 4. So we get time is less than equal to 10 seconds. What is the meaning of this? Up to 10 seconds, my assumption is right? Isn't that the meaning of this? Friction is saying up to 10 seconds, see, friction ka value you need is 2T by 5. At time T, if you can give friction 2T by 5, I can keep my assumption right. So up to 10 seconds, the friction can provide whatever you want. So the meaning of this statement is up to 10 seconds, they go together. For T less than 10, they go together. So up to T less than 10 seconds, they go together. Now for T greater than 10, they slip. Therefore, F is maximum. There, that is important. You have to prove it is slipping, and then only you can say F maximum. नहीं तो F का max, F max का बात ही मत करो. Always say F only. And then since it is slipping, draw those separate FBDs because they have different accelerations. So this guy will be F max, which is equal to 4, and this is acceleration A2 kg. Let's call it A1. So A1 is 2 meter per second square. If you take the 3 kg guy, this will be F max is equal to 4, and this would be F is equal to T. So this acceleration will be A2, which is T minus 4 by 3. So if you try to plot them on a graph, This is how the 2 kg block will look. Initially, what is the acceleration? T by 5. So it will go in a line, then it becomes constant. This is the acceleration of 2 kg. How much is this constant? 2 meter per second square. If you look at the 3 kg block, this also will go together, parallel line. Till when? Till 10 seconds, both will go together. And then this guy will branch off like this. A2 is the acceleration. And if you look at the slope here, this slope, look at this function here, T4 by, this is T by 3 minus 4 by 3. This looks like y is equal to mx plus c, a straight line equation. That is how I know. This angle is tan inverse 1 by 3. This angle, the slope here is 1 by 5. Tan inverse 1 by 5. Please check. This is how the graph looks. Up to 10 seconds, both will go together. After 10 seconds, the green line, the A2 will become constant and the 3 kg will start going faster. It will branch off. The graph will branch into 2 parts. That is how the graphs will look. Have a look at this. Ask me if you're confused. There you can. I hope you got understood how I'm getting those angles. If you're confused, please ask. Basically, it is from the slope. This is looking like y is equal to mx, m ka place mein 1 by 5. This is looking like y is equal to mx plus c, m ka place mein 1 by 3. So initially the slope of the line is tan inverse 1 by 5, tan theta 1 by 5, and then it is tan theta 1 by 3. Ritu, clear with this? Sure, no? This is a very important model, people, for 2 blocks. Please check it out. Ask me if you're confused. Look at it carefully. Ask me if you're confused. Let me give you one more like this. Clear? You can see I wrote it on the page. Right? You can verify, right, whether you're right or wrong. Why you need validation? You can see what I did. Is this clear, everyone? I won't be there in the exam to tell you you're right every time. So try, get it wrong, and that is fine. That is good. But even before starting, you want validation. It will be a problem. You will never build trust on yourself. Next one, see. We will change it a bit. I'll keep the numbers same, okay? 2 kg block, 3 kg block. Because the idea is important. F is equal to T. This time you're applying force on the upper block. Mu S is 0.3. Mu K is 0.1. The ground is smooth. Abhi dekh, mu S, mu K aa gaya. Now plot acceleration versus time graph for both the blocks. Let's see how you handle this. How does this look? There's some US and UK now. Try, leave a minute more. Okay, that looks weird answer, but let's see. Start with an assumption. Assume they go together. So remember this thing, the moment you see 2 or 3 blocks, start with this assumption. F is equal to T, and this is acceleration 2 kg, 3 kg, we get acceleration is equal to T by 5. Choose any one block. I'll choose the 3 kg guy. You can choose any one, doesn't matter. Friction on 3 kg will be forward. This guy is responsible for making it move. F is equal to 3a, that would be 3T by 5. And we know this F is 3T by 5 should be less than or equal to mu s n. Remember, until you slip, friction is static. 3T by 5 is less than equal to mu s is 0.3 and n is 20. How much is this? So T will be less than equal to 3.3.2, 10 seconds. Clear? So up to 10 seconds, there's no slipping. They go together. Now for T greater than 10, they slip. And friction becomes Fk. Now the values will change. Friction becomes kinetic. So if you draw the FBD now for the 2 kg, this will be time and this will be Fk, which is mu k is 0.1. The friction ka value will suddenly drop. That is 0.1 into 22 newtons. So this would be acceleration. So A1 will be T minus 2 by 2. So this is T by 2 minus 1. And if you take the 3 kg block, this friction Fk will be 2 and this acceleration will be A2. So A2 will be 2 by 3, which is constant. Look at how the graph looks. So if I draw the graph for the 3 kg guy, first it will go constant. This is the thing we are talking about till T by 5. This kind of looks like the previous one up to 10 seconds. And then the 3 kg will suddenly drop. Now look at this thing. At this point here, when you keep T is equal to 10, this value is 2 meter per second square. Then the value suddenly drops here and becomes like this. 2 by 3 meters per second square. This is the acceleration of 3 kg block. There's a sudden drop because friction value will suddenly drop. If you look at the 2 kg block, it is parallel. This is the thing which we are talking about. Put T is equal to 10 and see. If you put 10 here, we get 10 by 2 minus 1. That is 4 meter per second, meaning value will suddenly jump to here. It's a discontinuous function. And then it becomes a straight line. The graph will have a gap in the middle. There's a sudden discontinuity. This is a big hint. Whenever you have mu s and mu k, the graph should have holes in the graph. There should be discontinuity. That way you can actually eliminate options. You can't have continuous graphs when you have mu s and mu k. Because the value suddenly changes, you get a gap there. And this line ka slope would be tan inverse half. And initially this slope will be tan inverse 1 by 5. Please check how I wrote this. Because after 10 seconds, when the friction ka value, because think about it, friction ka maximum value was 4 Newton, 6 Newton, and suddenly it became 2. The blocks will feel a kind of a jerk kind of thing. The 3 kg will suddenly decelerate, whereas the 2 kg will suddenly, jump up the acceleration. This is the acceleration of 2 kg. Please check, it's a good one. Graphs will have a gap in this thing. Please check. Any doubts? Anyone not convinced? Please ask with any particular step. Ali, clear with this? Please check with the steps, everyone. Vartika, clear so far? Anika, clear? Ritu, Malika? Palaksh, clear? Niranjan, Ronak, Neil? Anyone has a doubt on this thing? Anything you're not convinced? Again, see how I'm teaching you. It's always a process. Follow the steps. Most of you, what you're doing, right? You see a problem and you try to random. You guys are not understanding how to start only most of the time. See, everything that I teach you, I always try to keep it in a format. Do this, do this, do this. When you learn like this, right? Even if something changes in the problem, you'll understand where to adjust. But if you try to randomly solve every problem without a proper, planning and format, you start getting confused in the exam. Understand? Final exam, mein you have 3 hours. Mains exam. 2 years ka portion. 3 different subjects. If you don't learn things systematically and if you don't grill them into your head, उस दिन exam में output नहीं आएगा. You will be there fully tensed. Every time you start this question, you should read in your mind. Assume both blocks go together and start. That is the reason when I taught you loss of motion, right? I taught you how to draw an FBD, steps to draw an FBD, steps to solve a problem, steps. I keep doing that every time. Because the more systematically you learn, the better the output will be in the end. If I give you, that 3 hours ka paper, if I give you 5 hours, I'm damn sure most of you will do very well. Nahi milega. You get 3 hours only. That is the problem. So when you study, keep that in mind. And you have to, most of you are not doing revision. That's what I was saying. Do multiple revisions. That is more important than doing 3 different books. I solved HC Verma 3 times. First time when I solved, I got answers. Second time when I solved, I really understood why I got answers. Third time when I did, I could actually figure out new methods to solve the same problem. And I cracked advanced exam with HC Verma. Thoda error kiya, but HC Verma is one which I did more thoroughly that time. Because we didn't have many books that time. So choose 1 or 2 books. Bas kafi hai. Do them thoroughly once, twice. Do the notes again and again. Let's see one more. Last one for the day. There. Ground is also having friction now. There is no mu k right now. Mu k next problem aayega. I'll put mu k on the ground also, mu k between the blocks also. Get this plot acceleration versus time graphs. How do you do this? You have friction on the ground. How would we start? In this case, right, first of all, blocks won't move for some time. Because देखो ना ground में friction है. Until unless you can break that friction, first of all, these blocks won't move only. So in this, there are three possibilities. Abhinav, you're asking now. This is the possibility. So first possibility, they will not move. Second possibility, they'll go together. Third possibility, they're slipping and going. Are you getting it? This problem will have three possibilities. Because previous case, the ground was smooth, they have to move. But because there's a friction on the ground, there is a chance both the blocks won't move for some time. So you can actually check that. If you look at the friction on the ground maximum, how much is this? 0.2 into 50 total normal reaction. That would be 10 newtons. Therefore, until and unless you apply 10 newtons, the system won't move only. So for 10 seconds, no one moves. Blocks won't move unless F is greater than or equal to F max. That is, T should be greater than or equal to 10 seconds. So for 10 seconds, no one moves. Up to 10 seconds, blocks are at rest. There. That is the first part in this problem. If you have a friction on the ground, you add one more possibility. They don't move, then they move together, then they separate. Now try from here. Okay. Then what we do? For t greater than 10 seconds, start with an assumption. Story is still the same. You just added one more point to the story. Assume blocks go together. Two kg, 3 kg. Since they're moving, the friction on the ground has to be maximum. How much is that? 10 newtons. And this is F is equal to T. And this is acceleration. We get T minus 10 is equal to 5A. Numbers will be a little bad there. T by 5 minus 2. Choose any one block. I'll choose the 2 kg block. The only one who's pushing it friction. F is equal to this. So F is equal to 2A, which is 2T by 5 minus 4. And this value should be less than equal to F maximum. U into N. That will be 2T by 5 minus 4 is less than equal to, this mu is how much? 0.3. 0.3 into N is 20 between them. So be careful, we are talking about different N's. When I talk about this surface, N is 20, this surface, N is 50. The lower surface. So 2T by 5 less than equal to, that is 6 plus 4, 10. T is less than equal to 25 seconds. It's up to 25 seconds they go together. So for T greater than 25 seconds, they slip. So this is saying up to 25 seconds, I can keep them together. Please check the steps. This is how you proceed. Now, if they're slipping, then your job's done. This friction becomes maximum, which is 6 newtons. So we get acceleration A1 is equal to 6 by 2, 3 meter per second square. This 3 kg will have two frictions, 10 newtons on the ground and 6 newtons on the top. We get acceleration A2 is equal to T minus 16 by 3. Check. These will be the accelerations. I'll just show you the graph. So if you try to plot this graph, initially they will not move, then they will go together, then this will become constant. This is that 2 kg guy. So up to 10 seconds, they will not move. Up to 25 seconds, they'll go together. And the value becomes constant at 3 meters per second square. Whereas the other guy, this will not move, then they'll go together, and then this will spike up. This is the acceleration of the 3 kg guy. This will be t by 3 minus 16. So this slope will be tan inverse 1 by 3. I hope everyone is understanding how am I getting these angles. And the initial slope will be t by 5. That is how the graph splits. You get a graph passing through time axis, then line, and then one. If you actually think about it, graph simply is a shift key, isn't it? You just shifted the graph by 10 seconds backward, a flat line. Please check the steps, everyone. So these kind of problems, whenever you have friction in the ground, you start with this. How much force you need to move the lower block, the total system, 10. So up to 10 seconds, no one moves. So after 10 seconds, assume they're going together. We got 25. After 25, they slip. Now put F maximum and solve. This is how we follow for 2 blocks ka process. Please check this out. If you understood this thing, you know how to do 2 blocks. Next class, we will do how to do 3 blocks. Block upon block upon block. Check it out. This is the last one for the day. So we have done almost like 18 problems so far, friction. So make sure to go through them, all of them again. You can start doing your HCV or a PACE booklet or whatever classes ko booklet you have to do. Start doing it. Wrap it up. Because next on Friday, we will wrap up the chapter in the first half of the class, and then we'll start off with circular motion introduction. If you see, the chapter is really not that different from laws of motion, right? It is always about finding that friction ka direction and magnitude. That is the only thing. And that is the main thing, actually. There's a more complex thing. I'll send you a sheet on friction today. So you can try that also for additional practice. But if you see the booklet that I gave you, right, you have enough questions there. That's what I'm saying. Don't run behind material. You finish your classes ka booklet, PACE, LN, jo bhi hai, what you're doing, finish off that. You can stick to my booklet. If you finish your booklet properly, you can go to my booklet level 4, 5, 6. It has pretty tough questions 5 and 6. Right? If you're finding, your booklet is also tough, then you do level 1, 2, 3, 4 in my booklet. So you have to, understand like what level you are and do accordingly. But main important thing, make sure to revise the notes multiple times. Okay, so with that, we'll wrap up for that day. So any doubts, anyone, any confusion, please ask in this or anything in today's class.